Example 7 talks about simplifying factorial expressions, which we're going to do later on for combinations and permutations. Anyway, 8 factorial, what I noticed about the bottom has 6 factorial on it. 2 factorial is 2 times 1. 6 factorial, I'm just going to leave the 6 factorial, and here's why. I can write 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 8 times 7 times 6 factorial. And so the 6 factorials cancel out. 2 goes into 8 4 times, and that leaves me 4 times 7 to make an answer of 28. Okay? Let's see another one of those just for fun. We'll call it, 7, 8.5. I don't know, it doesn't matter. If I have 10 factorial over 3 factorial times 7 factorial. Notice on the first one, I took the top number 8 and made it 10, or 8 times 7 times 6 factorial. I stopped because 6 factorial would be the same as 6 times 5 times 4 times 3 times 2 times 1. I just simplified that to make it 6 factorial because on the bottom I had a 6 factorial and they cancel out. So on this one, I'm going to take the 10, make it times 9, times 8, times 7 factorial, and stop at 7, because 7 factorial is on the bottom. I could have went down to 3, but since 7 is the big number, I went down to 7. Then 3 factorial is 3 times 2 times 1. Well, the 7 factorials cancel. 3 goes into 9 3 times, 2 goes into 4 8 times. I go 10 times 3 is 30, times 4 is 120. And the whole expression simplifies down to 120. On B, I'm going to use more of an abstract concept with n's. N factorial is the same thing as, or if we're going to work it backwards, instead of going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, I'm going to go forward and say it's 1 times 2 times 3 times 4 times ... whatever n is. Okay? So n minus 1 factorial, that means it's going to be 1 less than n, so 1 times 2 times 3 times 4, ... 1 less than n minus 1. And then this means I also have an n minus 1 here. Everything cancels out, leaving only the n. Kind of abstract, but mathematically it is logical.